Okay, so this is our next video on our mixed examples for the trig formula. So that's us identifying which formula we're going to use and then actually using it for the question. So we'll just jump straight to it. And again, I've got 3 examples for us to go through. So for the first one, we've got below is a triangle JKL. The area of the triangle is 18.5 meters squared. Angle KLJ is 51 degrees and KL has a length of 4.8 meters. Find the size of JL. So the thing I'm wanting to find out is this length here. So the fact it does mention what the area of the triangle is, that tells me we're going to be using our area formula. Now our area formula, we are given it as area equals half AB sine C. But I want to find out what one of my lengths is. So what I'm going to do first, I'm just going to change my letters so they resemble the A, B and C. So C has to be where my angle's at, so that's going to be C. And so this can be A and this can be B. So my unknown's at lowercase a and this will be my lowercase b. So what I'm going to do, I'm going to rearrange this formula in order to get the A as the subject. So to start off with, deal with that fraction. I'm going to times by 2 on both sides. So I've now got 2 times the area equals, and that will just be AB sine C. And then being multiplied with my A is this B sine C. So I want to divide that away. So dividing both sides by the B sine C. And so I'm now left with 2 times the area all over B sine C equals A. So that's the formula I'm going to use. So substituting into it, and while I'm at it, I am going to swap the A around to the front. I'm going to have 2 times my area is that 18.5 that we were told about earlier. So 2 times 18.5 all over my B is at 4.8 times sine 51. And so putting that all into my calculator, and that comes out as 9.9187 and so forth. And if I was to round it to 2 decimal places, that would just be 9.92 meters. Okay, let's take a look at the next one then. So here we've got below is triangle ABC. AB equals 8 meters, sine C equals 0.5, and sine A equals 0.6. Find the size of BC, and we are told this is a non-calculator question. So first I'm going to get down some of the information which we have. So AB is going to be that 8 meters. Sine C is that 0.5. So that doesn't mean this angle here is 0.5. It means I know sine whatever that angle is just going to be 0.5. And then same idea for the sine A. This is the other part that we know what sine that angle is going to give us. And we want to find out the length of BC. So to start off with, look at it. There's no mention of area, so it's not area of a triangle. We have one side and we're finding the second side, so it's not cosine. So that means left it is going to be our sine rule. And again, we can spot we've got 2 angles and one side needing to find the second side. So my sine rule is that A over sine A equals B over sine B equals C over sine C. So starting off with my usual steps, I'm going to work through it and tick the information I do know. So my lowercase a is what I want to find out. It's this length here. And in fact, I should label the opposites. That's my lowercase a, lowercase c, and lowercase b. And my sine A, I know we are told it up here. So I'm going to give that a tick. My lowercase b I've got nothing for, my sine b I've got nothing for, my sine c is that 8 here, so I'm going to give that a tick, my lowercase c even, and my sine c we are told what it is here, so I'm going to give that a tick as well. So I'm not using the sine b one. So substituting into that then, so my lowercase a I still don't know, so that's going to stay as a. Now my sine a, we are specifically told sine a equals 0.6. So that's just going to be 0.6 there. And then my lowercase c is 8. And my sine c, we are specifically told sine c equals 0.5. So then doing my rearranging trick, a is the thing I want, so I'm going to write a equals. Multiply across that diagonal, so I've now got 8 times that 0.6 and divide by the last thing on the bottom. And so from here, I now need to start working through and finding that final answer for a. So if need be, you can always set up little chimney sums to help with it. 6 times 8 is going to be 48. So that's just now going to be a equals 4.8 over that 0.5. And if you divide something by a half, because what I've got there, I'm essentially saying 4.8 divided by, and 0.5 is a half. And if you remember back when you did all the fraction work, whenever you would divide by a fraction, in order to help figure out what it is, you can change the sign and flip the fraction upside down. And so what I've essentially got is 4.8 times 2. So my final answer is going to be a equals 9.6. And it'll be 9.6 meters. Okay, last question then. So here we've got find the size of the smallest angle. So it's not telling us which angle in particular to look at here. We just want to find out the smallest one. So to start off with, there's no mention of area, so it's not in my area formula. I've got 3 sides and I'm finding an angle, so that means it's my cosine formula, and specifically the cos A equals b squared plus c squared minus a squared all over 2bc. So we could go about it and find all the potential angles and then identify which is the smallest, but the smallest side is always opposite the smallest angle. So my smallest angle is going to be this one here. So A needs to be where my unknown's at, so I'm going to label this as A. And then the B and the C don't really matter, so that can be B and this can be C. So then substituting into that formula, I'm going to have cos A equals 125 squared plus 150 squared minus 71 squared. All over 2 times 125 times 150. So putting that into my calculator initially so it can do a little bit of simplification. You normally get a mark for this all simplified fraction. And that's going to come out as 2,757 all over 3,125. But that's cos A. I want to find out what A is, so I need to do the cos inverse of that fraction. And so putting that into my calculator, that just comes out as 28.0862 and so forth. And so rounding that to 2 decimal places is just going to be 28.09, and that'll be degrees. So hopefully that's helped out a bit with identifying which formula to use and how to then actually use the formulas. Let me know if you have any questions at all. With our trig work, this is probably quite a big topic. It's a really good one to get marks in because you are given all the formula. The hard part is just identifying and knowing how to use that formula. But good luck with any of the work, and yeah, let me know if you need any help.